In this video, we will graph sine or cosine using period, midline, amplitude, and phase shift. Problem number 1. Let's start with the period. How do we calculate the period? Well, the period is equal to 2 pi divided by the b value. In this case, the b value is this 2 right here. So that means 2 pi over 2. Of course, the 2's cancel out. That means the period is pi. Now, what do I do with that? I like to put the period right here. Alright, so the period is pi. That means if I go halfway, that's going to be pi divided by 2. If I go half of that, that'll be pi over 4. Now, if I go to here, that's 3 of these, so that'll be 3 pi over 4. So that's how we label that. Now let's talk about the midline. The midline is going to come from this number right here because of a vertical shift. So the new midline, instead of being the x-axis, will be the line y equals 3. Let's go ahead and graph that. So there's the midline. Now let's talk about the amplitude. The amplitude is going to be 1/2. Alright, amplitude is always positive, so the amplitude is going to be 1/2. It's coming from this number right here. Now the negative sign does mean that we're looking at a reflection over the x-axis. So it's going to be upside down. Now the function is a cosine function, and we learned long ago the basic graph of sine and cosine. Whereas sine always starts from the midline and goes up or down, cosine never starts at the midline. Cosine starts at the amplitude. So if it's positive, it's going to start off at positive amplitude. If it's negative, it's going to start off at negative amplitude. But it starts off at the amplitude. So because we're dealing with a negative cosine, we're looking for it to start low, then go to the midline, and then up, and then back to the midline and down. Alright, sort of like a hill. Okay, so because I'm not doing the phase shift yet, I am going to draw what I call a skeleton graph, the unshifted graph. I will not connect these dots. So the amplitude is 1/2, but it's negative 1/2. So I'm going to start off my cosine function 1/2 below the midline. Alright, next I'm going to come up to the midline. Then I'll go above the midline, but again the amplitude is 1/2, so I'm just going to go up half of a unit, and then back to the midline, and then at the end of my period here at pi, I should of course end up right back where I started from. So these are the 5 key values that will make up my skeleton graph. Now these values will be shifted according to the phase shift. Okay? In the end, I'm going to want to graph as much as I can fit on this grid. So I'm going to even continue my skeleton using the same pattern. So if I were to continue this, now that I'm down at the bottom, if I went the same number of spaces over again, I would end up back at the midline, and then I'd end up halfway up again. You know, it's like a wave. It goes down, it goes up, it goes down, it goes up, it goes down, it goes up. So I could continue the pattern like this. So this would be the skeleton continued. Now let's talk about the phase shift, which is going to be a horizontal translation either to the left or to the right. Well, the phase shift happens when you have something added or subtracted on the end inside of the parentheses. But now that I look at it more closely, there is no phase shift. The phase shift is going to be 0. Now if this had been, you know, like 2x plus 4 or something like that inside the parentheses, this is where the phase shift would begin to happen. But with nothing being added or subtracted in there, there is no phase shift. That means this is the actual function. not just the skeleton. So I am going to go ahead and just connect these dots and let that be my answer. I'm sort of missing. Alright, so your graph should look something like this. You see the pink part here, this is one period, that first period, and then the purple part is what you would get if you just extended that as far as you can. Anyway, that's problem number 1. Let's do a couple more. Alright, so problem number 2. Again, let's start with the period. The period, once again, is 2 pi divided by the b value, which once again is 2, alright, just like it was in problem number 1. So once again, the period is going to be pi. So this is going to be real familiar. So once again, there will be pi here, and half of that is pi over 2. Then half of that is going to be pi over 4. And then 3 of these, 1, 2, 3, is going to be 3 pi over 4, just like before. Okay, this time, alright, unlike in problem number 1, which had a midline change, a vertical shift of +3, this time there is nothing added on the end. So it's like having a +0. That's why the midline is going to just remain y equals 0, which is the x-axis. Okay, so no need to draw it, it's already there. The amplitude is going to be 5. Okay, the amplitude is going to be 5 because you see the 5 is right there. Again, I might as well mention right now, there is no phase shift. There's nothing being like added on inside of the parentheses or anything, so there is no phase shift. So we are dealing with a sine function, and we have learned that the sine function always starts off at the midline, and if it's positive, it goes up first and then down. So it is positive, so that's what we're going to do. We're going to start off by going up and then down. So because this has no phase shift, these will be my actual points. So starting at 0, I'm going to go up the amplitude. Okay, 1, 2, 3, 4, 5. So up 5, and then back down to the midline, and then down 5, and then back to the midline. So these 5 points reflect one period of this graph. And so I could graph that right now because there's no phase shift or anything. So that would look like this. Okay, so this is a little bit hard to draw with an electronic pen, but I'm going to do my very best. Alright, it gets a little bumpy in there, but you get the idea. That's what one period of this thing would look like. Now I'm going to extend the pattern in purple to see what would happen filling the rest of my graph. So you can see it's going down and up, and so it's going to go down and up again. So it would go again down 5 because that's the amplitude, and back. So if I continue the pattern, alright, this is a little bit too pointy. Alright, it's got to be a little bit more rounded like this. Okay, so that's what it would look like extended over here, and then of course it would go up and back again. Okay, so that's what the rest of the graph would look like. I mean, here's one period of it, and then there's what it would look like extended. Okay, so that's what problem number 2 is all about. Let's look at a couple more. Let's see, how many more of these do we actually have? Alright, so 2 more. We're going to do 3 and 4. So, getting more interesting now. Alright, we have some stuff. Alright, this one seems to have everything on it. But let's start with that period. Once again, the period is 2 pi divided by the b value. In this case, the b value is 1/2. So understand that that means 2 pi divided by 1/2, alright? And you probably know that when you divide by a fraction, that's the same thing as multiplying by the reciprocal. So 2 pi times 2. So that's why you're going to get 4 pi for the period. Alright, so the period is 4 pi. So let's go ahead and put that on our graph. Alright, if this is 4 pi, then that means this is 2 pi, which makes this 1 pi, or just pi, and that makes this 3 pi. Alright, this is always 3 of these, because 1, 2, 3. There it is. So there we have that. You know what? I've been not labeling the y-axis. Let me do that. So this should have been, I was just counting by ones, so that's why I was slacking off a little bit. But I should always label these. -4, -5. And it was the same thing on problem number 1. Okay, this was 1, 2, 3, 4, 5, and -1, -2, -3, -4, -5. Because sometimes we do change the scale on the y-axis, so we can't just assume that we're going by ones. Okay, so we'll see about this. Alright, but chances are we're going to count by ones again. So 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Now, equation of the midline is going to come from this right here. So it's going to be y equals 1. Let's go ahead and draw that. Alright, of course the amplitude is 3, which you can see right there. Now this is enough information for us to draw the skeleton. I see I am going to have a phase shift this time. So I will have a skeleton which will wind up moving. But let's go ahead and graph the skeleton. This is a sine function, so the sine function is going to start on the midline, alright, as we've seen. Because it is a positive amplitude, well, not a positive, amplitude's always positive, but because the leading coefficient is positive, I know the sine function is going to go up first and then down. So it's going to go up by the amplitude from here. So it's going to go up 3, and then back to the midline, and then down 3, and then back to the midline. Okay, so this would be my skeleton. I am not going to connect these dots. Alright, however, I can continue the pattern of the skeleton. Alright, if I went further, alright, I went up, I went down, it would go up again. Alright, again it would go up the amplitude, and then it would come back down once again. Alright, and I could continue the pattern going this way. Alright, it went up and then down and then up, and then it would go down again and then back to the midline. So here's what the rest of the skeleton would look like. Now that's important because I want to fill the graph as much as I can. But now let's talk about that phase shift, that pesky phase shift. The phase shift is going to come from this part of the graph, the part that's 1/2 x plus pi over 2. Pi over 2 is not the phase shift. Alright, we don't get the phase shift until we factor out this coefficient. So if I can bring this 1/2 outside of parentheses, then I'm going to get my phase shift right here. But the only way to do that is by division. So what I'm really doing is I'm dividing both of these by 1/2. Alright, that tells me what I'm going to get on the inside here. So these cancel out, that just gives me x. But to find out what goes here, I'm doing pi over 2 divided by 1/2. Well, let's do that off to the side. I've got pi over 2 divided by 1/2. Well, that's the same thing as pi over 2 times 2. Alright, I'm multiplying by the reciprocal. But these 2's will cancel, so I'm just going to get pi. Now if you're uncomfortable with that at all, understand I could have put this in my calculator. Pi over 2 divided by 1/2. Okay, so I could have done pi over 2 divided by 1/2. Okay, either way I'm going to get pi. Okay, and with the 1/2 out front like that, that means this will be the phase shift. Except for it's the opposite of the sign. So it's actually going to be a negative pi, which means that we are going to the left. So I need to move each one of these skeleton points to the left pi. How big is pi on this graph? Well, you can see pi right here. Notice that it is 2 squares in size. So I'm going to move each one of these green skeleton points 2 units, well, 2 squares to the left, because that's how much pi is. So this one will move, if I move 2 squares to the left, it will become here. This will land here. This will go here. This one will end up here. This one will be here. This one will land here. This one will land here. And this one will land here. Once you get the first dot going, you really can begin to follow the pattern. So I can see that it's going to be doing like this. Okay, and to extend it just a little bit more, I can tell that if I kept going, it would end up right here. So I could even just go a little bit more. Okay, so here's a full graph as much as will fit on this grid. Now, if you were keeping your eye on that initial 5-point period, when we went here, 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 that has ended up right here. If you just wanted to keep an eye on what happened to that initial 1 period, well, there it is. You can see that it shifted pi to the left. Alright, and the rest of it is our extension. Okay, let's look at one more of these. Alright, this will be the last graph on this video. Let's start with the period. The period is 2 pi divided by the b value. Well, this time the only b value is 1. So really that just means the period is the 2 pi that we first learned about when we learned about the parent function of cosine and sine. So the period is going to be 2 pi. So that means, let's go ahead and put 2 pi right here. That means this will just be pi, and this will be pi over 2, and that makes this 3 pi over 2. Okay, now, so this let's label the y-axis as well. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Now, as far as the equation of the midline, it's still going to be the x-axis, y equals 0, because there's nothing being added on here. So y equals 0. Now the amplitude is going to be 2, alright, because of this right here. Now there is a phase shift, so let's graph the skeleton. The skeleton comes from the information that we already have. This is a cosine function, which means it will start at the amplitude, not at the midline. Because it is positive, I know to start off up high. Okay, and then I'll go low. So I'm going to start off at 2 with my skeleton. Then I'm going to go down to the midline, then below the midline, back to the midline, and then above the midline. Alright, as we've learned before, this is how cosine goes when it's positive. Alright, now that's the skeleton. There is going to be a phase shift happening, but before I get into the phase shift, I'm going to actually continue the skeleton. So if this skeleton continued, it would go back down to the midline like this. Okay, here's how it would continue. And this is now high, so it would go back to the midline and then like this. So that would be the rest of this skeleton. Alright, now let's talk about that phase shift. So remember, the phase shift comes from this part of the graph, the equation x minus pi over 2. Now when there's a b value, I have to pull that outside of the parentheses, but the b value is just a 1. You know, there is no b value other than 1. That means that this pi over 2 actually is the phase shift. So it's going to be pi over 2. It's going to be opposite in sign. So it will be positive pi over 2, meaning that we're shifting to the right. Okay, so each one of these skeleton dots is going to have to shift to the right. So that means I'm going to go to the right by pi over 2. Look where pi over 2 is. Pi over 2 is 2 squares in size. So that means I'm going to be shifting 2 squares to the right. So this will land here. And this will land here, and here, and here, and here. Alright, I moved each one of these green dots to the right. Okay, so just looking at this one period, you can tell it would look like this. Okay, messed up there at the end, but you get the idea. So there's one period worth. But let's continue the pattern and see what would happen. Alright, if I continued the pattern of I'm going down and then up, obviously I'm going to go back down again. So I would go like this. Okay, so I could continue this pattern like so. Alright, and if I continue to the right, it would go back down again. Alright, so this nice pink area right here would be the one period that we sort of begin with, but the purple shows how I could extend it to the edges of my graph. So that is it for problem number 4, and that's going to be the end of this video.